Welcome back to True North Mechatronics. In this episode, we're moving back to the front of the mobility base to add a mount for an ultrasonic sensor, but first we need to make a quick height adjustment to our motors. Our drive motors need to sit exactly 1 millimeter higher off the mobility base for optimal clearance, so before we tackle that sensor bezel, we're just going to quickly create this sensor mount as a rectangle with two 3 millimeter holes. And if you remember back to part 2, we engineered a specific clearance notch in the front of our accessory deck, and that was to accommodate our sensor bezel here. Design, engineer, deploy. Let's get into the CAD. Begin by creating a new body and a new sketch on the XY plane. We're going to create that motor shim first by creating a rectangle. We'll make it symmetric around the around the origin. Let's set its horizontal to 15 millimeters, and its vertical is going to be set to 5 millimeters. And now we need to put those two holes in the center of it because the mounting brackets use 3 millimeter bolts. We're going to create two 3 millimeter holes. So we'll set the diameters equal to each other. We'll set the diameter to 3. Actually, let's set it to 3.2. That way the bolt has a little bit of clearance. We're going to make these holes so that they are symmetric with respect to the origin here. And now we just need to set the distance between them. So the distance between these holes needs to be set to 8 millimeters. And that roughs out the shape of the shim. We just need to pad this shape out to 1 millimeter. And there we are. There's our motor shim, as simple as that. So let's rename this and call it shim. And you're going to need 2 of those, 1 for each of your TT gearboxes. All right, I'm just going to hide that for right now, and I'm going to create a new body and a new sketch on the XY axis. We're going to begin with a rectangle that we're going to make symmetric around the origin. And after we've done that, we're going to set the dimensions on this. So the horizontal dimension is going to be 48 millimeters, and our vertical dimension will be 10 millimeters. Then we're going to add our 2 mounting holes. So let's go right to the x-axis here. We'll make these holes coincident with the x-axis. Let's set the diameter equal to each other, and we're also going to make these holes symmetric around the y-axis. So the diameter for these holes is going to be 2.8 millimeters. That's the minor diameter on the PT screws we're assembling the robots with. And we need a separation between these 2 holes of 36 millimeters. And with that, we've fully constrained the starting point for our sensor bezel. Now we're going to pad this shape out to 9 millimeters. And so now that we've done that, we are going to just clear away some of the plastic that we don't need from the middle of the bezel here. So left click on the top face, create a sketch, and we're going to leave a 3 millimeter ledge up at the front here. So let's reference the bottom edge of our bracket here, and let's grab the rectangle tool. And let's make this rectangle so that it's symmetric with respect to the y-axis. Let's give it a vertical dimension of 7 millimeters and a length of 25 millimeters. So that leaves enough plastic around the holes for the screws to bite into without the plastic separating. So we can close out of this, and we're going to pocket this shape all the way through. So that was 9 millimeter thickness, so 9 millimeters will clear it. And now we're going to add a shoulder on the top of this block that we've built so far. So again, create a new sketch, and we're going to reference the top edge here and grab that rectangle tool, and we're just going to come in, and we're going to make sure that the other edge of that rectangle is coincident with the edge of that line. And let's give our line a thickness of 3 millimeters. And with that, this is fully constrained, so we can close out of the Sketcher workbench. And we're going to pad this shape out to 21 millimeters. All right, so now we're going to flip around to the front face here, and we're going to add a sketch on the front face. So let's do that. Now these are going to be the holes that will allow our ultrasonic sensor to pop through, so that the sender and receiver units can pick up the ultrasonic sounds. So we're going to create feature holes for the transmitter and receiver. Let's make both of these holes so that they have an equal diameter. We'll make both of these holes symmetric around the y-axis. And let's set the diameter on these holes to 16.4. So what we did was use a set of calipers and measured the diameter on the circular transmitter and receiver, and then added 0.2 millimeters for clearance. So that's how we came up with that number there. The distance between these two holes is going to be 26 millimeters. And now we need to create a slot to allow the crystal oscillator. This is a slot-shaped can that sits between these two units. So we'll just use the slot tool here, and we'll make sure that this slot is horizontally constrained, which it is. And we're going to set the internal length here of our slot. We'll set that to 6.4 millimeters. Let's set the radius of the terminating arcs here on our slot to 2 millimeters. We're going to make this slot so that it's symmetric around the y-axis. And now we need to set the location with respect to these sending units here. So we're going to create an offset here of 7 millimeters. So there we are. Now we need to constrain the location of this larger shape here. So we're going to set it with respect to the top of our bracket. And let's create an offset distance here of 10.5 millimeters. So these primary shapes are now locked into place. And let's close out of the Sketcher workbench and pocket those all the way through. Now that we've done that, we need to make a modification on the other side. The ultrasonic sensor has some through-hole components specifically for the DuPont wire pins that come through that send the signals to the microcontroller. So we've got to put a clearance pocket here on the top inside edge. So click on that front face, click on Create Sketch, and we are going to reference this top edge here, and the rectangle will be coincident with the top edge. We're going to make this rectangle symmetric with respect to the y-axis, and we're going to set the length of this to 10 millimeters, and its vertical dimension will be 3 millimeters, and this accommodates the through-hole components that poke through the back of the circuit board for this sensor. So we're going to close this now, and we're going to pocket this shape out to 1.7 millimeters. And that gives us just the pocket there. Now, when we press the ultrasonic sensor up against this face here, we discover that the crystal oscillator has a little ledge. And so even though the main part of the can fits through, there's a little ledge that we need to accommodate. So we're going to add one more feature to this face here. And we're just going to widen out this slot. We're going to create a stepped feature. So let's reference these edges first. Now, for some reason, FreeCAD version 1.0.2 seems to have trouble with maintaining these coincident lines here. So when I left click, I get this auto remove redundancies, and I'm no longer locked into place there. So I'm going to come in and I'm going to manually realign those so that they are coincident. Don't be fooled if it looks like it aligned itself. Move it, because it's not. So click on them both, constrain coincidence. So we've now locked that in. So the 1 degree of freedom is the radius on our terminating arc here. And we're going to set that radius to 2.75. So that's all we need to do to clear the step feature on the crystal oscillator can. So we're going to close out of this. and we're going to pocket this step to 0.6 millimeters. And that will allow the ultrasonic sensor now to sit flush against this mount that we just created. Our final step is to clearance these corner edges. So I'm going to hold down Control, left click on both of those. I'm going to give them a chamfer of 2.5 millimeters. Okay, so that completes our front end obstacle detection sensor bracket. We've successfully iterated on our drive geometry by adding that 1 millimeter shim, and we've engineered a rigid bracket for our ultrasonic sensor. Seeing the bracket perfectly slide into the clearance notch we designed weeks ago will be the ultimate payoff when you print this and attach it to the front of your accessory deck. So we are going to continue to build out the front end. In our next video, we have a guard that we need to build and place around the lenses on our infrared sensors that extend below the bottom of the deck. Chart your course, build your world. I'll see you in the next one.